Hi friends, welcome to another video on my YouTube channel. I was thinking to learn some basics of AI and ML, and I will be making videos on concepts I will be learning in the week by the end of the week. So in this video, we are going to learn about neural network, which is like the first step while in training a AI model. So a neural network is built using multiple neurons. It's a structure of neurons linked to each other, and a neuron or a node is a sometimes called a perceptron as well. Is a basic building block to build a neural network. It just processes the input data and passes the information forward in the network. So if you look at this diagram here, this is called a neuron. It takes multiple inputs. There can be multiple layer of inputs. So here in the diagram I have just taken two, but there can be as many as you want. So it will just take those input, it will just perform some operations on it, some mathematical operations. Let's say, for example, let's say sum these two and pass them through an activation function. We will look into that part, and after that it will just output the result of the neuron. So it's a simplified model of a biological neuron in the brain. So meaning in our brain as well, there are neurons, a layer of neurons, right? That passes signal from one neuron to another to make our body function. So whenever our brain gives a signal to a neuron, it just processes that and pass it to the other neuron it is linked to. Same happens in a neural network. So there will be a multiple layer of neurons, and each neuron will pass an output to other neuron. So structure of a neuron in a neural network will be something like this. It will take inputs, values coming from a data set or from other neurons. So there we'll look into this. So there can be multiple layers of neurons. When you build a neural network, there can be multiple layers of the neurons, and each layer can have multiple neurons as well. So the first layer, that is facing the input data, that will take the input from the data set, maybe a CSV file or array or something. It will just take the data from the inputs and it will do some operations on it, and the output of those neurons will be passed to each neuron in the next layer as the input. Weights. So each neuron has a weightage added to each input field. So for example, let's say we have two inputs here. So there will be two weights assigned to each input for a particular neuron. So for example, let's say we have n number of inputs, and there will be n number of weights. So let's take the example of this neuron. Let's say we are passing n inputs to this neuron. Then there will be n weights assigned for each input in this neuron, and a bias. Bias is another parameter that is needed for the calculation in a neuron. We will look into it, how it is used and why it is used here. So each weight will be multiplied by its own respective input, and the summation will be added to the bias, and that will be the output of the summation of the neuron. There will be an activation function as well, through which this sum will be passed, so that this is not a linear equation anymore. So as you can see, no matter how many inputs are there, this will always be a linear equation, right? So if the linear equation is there, a neuron will not be able to learn more complex scenarios like image processing and all. So to avoid that, we pass this result as an activation function from an activation function, and after that the final output is the output of the neuron, and which is passed to other layers. So after the summation, activation function is there, sum is passed through a function and introduce the non-linearity in the network to learn complex patterns. So after this, output is sent to the other layers in the neurons. So neuron learns which inputs matter most by adjusting its weights and bias during the training. So that is the role of the weights and bias in the whole equation. For example, let's say there can be multiple inputs for a use case, right? For example, let's say in image there will be multiple inputs, or let's say you have a whole huge CSV file with huge large number of columns, and you're passing that as an input in a neuron, right? So there can be some columns that are not necessary for your calculation, or they have less priority over others. So to find out which input parameter is most useful for learning, or to give with what priority to give to what input, weights are used here. So the parameter that is more important to your calculation for our learning, that will have more weight, and the parameter that has less importance in your calculation or less priority, that will have less weight. So accordingly, the weights will be decided and adjusted on a neuron. Without neurons or layers of them, a neural network would be just a linear equation and couldn't capture complex relationships. So this is the process we follow. First, each input is multiplied by its own weight. Then we do the summation of them as well as with the bias. Then the sum is passed through an activation function, and that becomes the output of the neuron. So here I have just taken an example. So let's say we have two inputs, x equal to 2 and 3. So I have just taken array as an input. So each neuron will be passed this input, and let's say for the neuron we have weights as 0 and 1 and bias as 4. So 0 will be multiplied by 2 and 1 will be multiplied by 3, and bias will be added on the whole result. So that gives us 7. Now here I'm just taking an activation function. After this is called dot product. When we multiply things like that, this is called the dot product. After this, it will be passed through an activation function, and that the result will be 0.999, let's say. So this is how the calculation happens on a single neuron. Please note, this is not a neural network. It is just the processing that happens on a single neuron. So again, weights, they decide the importance of each input. If the weight is large positive, then the input strongly pushes the neuron's output up, and if the weight is largely negative, the input strongly pushes the output down. So if the weight is 0, the input is ignored. So for example, the same in CSV column, if you want your few columns or few inputs of your CSV to not have any effect on the calculation, you can just put the weight 0 for them, or maybe remove from the CSV file altogether. If not, you can put the weights 0, and they will not be given any importance in the calculation, because this part will make them 0, and they will not be passed to the other layers. Now let's example. Some inputs are, for example, let's say R studied and R slept while practicing for exam. So let's say you are learning for an exam, and there can be two parameters that will affect your preparation, which is number of hours you are studying and the number of hours you are sleeping. So both are needed, right? If you keep on studying and you will not sleep, then also you will not be able to learn things, right? Plus, if you will keep on sleeping and do not study, you will not be able to prepare for the exam. So we cannot remove any of the input parameter in this scenario. But as we know, sleeping less is needed. Sleeping is less priority here, right? So you need to study more. So that is why we may, let's say, put a weight of 0.8 for the hours studied and 0.2 for the hours slept. This is how we can decide weight based on the importance of our input. Bias just shifts the decision boundary of the neural flexibility. So here, if you look into this formula, here if we remove the bias from here, we have just input into weights, right? So let's say for all inputs as 0, this equation will be 0, right? So if we do not add bias to the whole calculation, the function will always pass through the origin on a graph, right? If you form a graph for different inputs for this function, then for all the inputs as a 0, this will always pass through the origin. So bias shifts the decision boundary and gives the neuron flexibility on top of that. So without bias, the neuron always passes through the origin, which is true restrictive for the learning processes on the complex functions. So bias allows the network to fit the data better, even when the inputs are 0. So it's like a y-intercept in a equation. For example, y equal to mc plus c, where c is the bias and m is the weight. Activation function introduces non-linearity. So after adding bias as well, this is just a linear equation, right? So complex algorithms or complex scenarios where you need to recognize image or text processing, these are not linear things, right? You cannot fit them in a linear equation, right? So to perform these kinds of learning, the input is the summation is passed into an activation function, so that the neural network is able to learn complex patterns like curves, shapes, boundaries. So to make them learn about all these things, the activation function is used. So there are three very common activation functions that can be used as the beginner level, which are sigmoid, 10h and ReLU. So sigmoid is a function which squashes the values between 0 and 1. 10h is a function which squashes the values between -1 and 1, and ReLU keeps the positive values, zeros out and negatives out. So most of the time in this video or in the upcoming video as well, we will be using sigmoid function as our activation function, because it will just pushes every input to 0 1. No matter what input you provide to a sigmoid function, the output will be between 0 and 1. Combining neurons in a neural network. So this is how a neural network is formed using the neurons. So first we have an input layer, which is our input either from a CSV or an array or something. Then those inputs are passed to a layer of neurons, which is one neuron. Let's say the output of these neurons is H1 and H2, and the output of these two neurons will be passed to the final layer, which is output neuron, because we don't have a layer after that, right? So there can be many more layers of neurons between these two. So there can be one hidden layer, then second hidden layer, then third hidden layer, then the output layer. So there can be as many as number of layers depending on your scenario or how complex your scenario is. There can be multiple layers and much more multiple neurons in a particular layer. So here, for the simplicity of the calculation and for the simplicity of example, I have just taken two inputs and then a single output neuron, but there can be thousands of neurons in a single layer, as well as there can be hundreds and thousands of layers of neuron before the output layer. So a layer is a collection of neurons working in parallel. Each neuron in a layer gets the same inputs but applies its own weights and bias, producing different outputs. Outputs of one layer becomes input for the next layer. So this is how the basic training works in a neural network. So you can have multiple inputs, n number of inputs. Each neuron will receive all those inputs. So let's say there are n inputs. All those n inputs will be passed to each of the neuron in the first layer. Each neuron will have its own weight, own bias. It will produce a different output for the same inputs, and then the output of each neuron will be passed to each neuron of the next layer. So here we have just output layer, right? So output of these two neurons is passed to this output neuron, right? But let's say if there was another layer in between, another hidden layer, then the output of H1 and H2 will be passed to each neuron as an input to the each neuron of another the second layer in between. Then the output of that layer will be passed as an input to this output neuron, and so on. So this is how the neural network is formed. So layers in the neural network I've already explained. There is an input layer, then the hidden layers. There can be multiple hidden layers between an output and an input layer, and more layers. Ability to learn more as the number of layers or the number of neurons in a layer increases. The ability to learn more complex representation is given to a neural network. Output layer, it just provides the final result. So when the output layer gives the result, that becomes our prediction. For example, let's say the same scenario we have taken away number of hours studied, number of hours slept. For example, let's say we have some data where students who have slept these many number of hours and studied these many number of hours, they have passed or failed the exam. So depending on that, we train a neural network. Then let's say we give a random input, some new input, that this student has slept for these many number of hours and studied for these many number of hours, and then our neural network will be able to predict if that student will pass the exam or fail the exam. So that prediction is the final output layer of the neural network. So flow of information, I've already explained. Inputs are passed with multiplied by weights and bias, passed through the activation function, and output goes to the next layer of neurons. This keeps on repeating until the output layer is reached, and then this whole process is called forward pass. So if you have heard about few terms, you know there is something called back propagation, but before that, this forward propagation of the info happens in the neural network. This flow of information from input to hidden layer, then to another hidden layer, then to another hidden layer, then finally to the output layer. This flow of information is called forward pass in a neural network. So why are we combining neurons? Because a single neuron is like a straight line decision, right? A single linear equation, right? Many neurons together can approximate any complex function. There is a theorem called universal approximation theorem, which suggests this thing only, that multiple neurons, if we combine multiple neurons together, we can learn, that neural network will be able to learn anything you want. So that is why deep networks can recognize images they can understand speech and play chess as well. So as you already know, we have some few AIs, many AI models that are able to play chess with you, and ChatGPT and all those things nowadays, right? That they recognize every speech and all those things because they have a huge layer of a neural network somewhere already trained with a huge amount of data set, and that is why they are able to perform all those operations. Universal approximation theorem. So this theorem states that a feed-forward neural network with at least one hidden layer containing a finite number of neurons and using a suitable activation function can approximate any continuous function on a compact subset of R to the power n to any desired degree of accuracy. So if we simplify this theorem, it just says that if you give a function x with some inputs, for example images. For example, there is a scenario where you provide images as an input to a neural network, and you want to know what type of image is it. You just want to output it a label, for example, an Apple image or a car image or a bus image. So you just want to know, you just want an output as the what image is it. It's a bus, it's a car, or it's a fruit, something like that. That is also that can also be learned by the neuron, right? You might have already seen things like that because so this activation function says this thing only: if you give me any function x that is a complex function or a simple function and enough number of neurons in just one hidden layer. So even if you create one hidden layer and we just provide a enough amount of neurons in that hidden layer, any complex function can be learned through that hidden layer only with the approximate weights and all those things. So network can approximately mimic the function x as closely as we want. This is what the approximation theorem states. So in theory, a neural network is a universal function approximator. It can mimic any function you want, and it can represent very complex patterns as well, no matter they are linear or non-linear. So it explains why the neural networks nowadays are so powerful. They are not limited to linear relationships, and with enough neurons, they can represent any type of function like curves, steps, oscillations, images, text to speech, and everything. This is the mathematical justification of the neurons that's in the practice. So key details: hidden layer. You don't need many hidden layers. Even one hidden layer is enough in the theory. So this theorem says that you don't need many hidden layers to mimic a function. When the data set is used and the function becomes more complex, you might need more hidden layers. But it states that even if you provide one hidden layer and with the enough number of neurons in the layer, it could mimic any function very closely. But in the practice, obviously, deeper networks have many hidden layers to learn more efficiently. Activation function should be a non-linear function because the goal of this function is to remove the linearity between the calculation, right? So if you will take a linear function only, then it will not serve the purpose. So that is why activation function should always be a non-linear function. Compact subset. This means the input space is bounded. So for example, it says that when the input space is bounded means you provide a bounded set of data. You do not provide everything you want. Like for example, if you are building a image recognizer, so you are providing images of car and everything, then you want to identify if it's a car or not. You cannot provide text to that, right? So depending on your problem, input should be bounded. So if you want the network to recognize your images, you have to provide data like that. You cannot provide anything to it like text or something like that. This is what it says. An example of feedforward information. I've just taken the example again. So here h1 and h2 equal to w into x plus v. So I'm just taking same weights for all the neurons here. So as we have seen this neural network, right, h1 and h2. So I'm just taking the same weights for both the neurons and similar. So the value of h1 and h2 will be 0 into 2 and 1 into 3 plus 0. Just taking the bias as 0. It will be 0.9526. Then this will be passed as an input to the output neuron, which will be multiplied by its own weight, and the same thing will happen: 0 into h1 and 1 into h2. These are the weights, and the bias is taken 0. So the input is passed as h1 and h2, and the final output will be 0.7216. This is our prediction. So this is just an example. let's look into the code how we write code for this in Python. Yeah, so here I've just written a neuron class in Python. So it will just take some weights as the input. So when creating this neuron class, we'll pass some weights and the bias. I'm just setting up those weights and the bias. So I'm just performing a simple calculation that a neuron does. For example, I've just written a function called feedforward. It will just create a dot. It will just do a dot product of weights and the inputs and add bias to it, and it will just pass this to an activation function, which is sigmoid function, and it will just return the output. So this is what a neuron looks like. Let's try to run it. Uh, I'm just using the virtual environment. Let me activate that. And Python 3 neuron.py. So this is the output of our neuron. So I'm just passing some inputs to it. Let's go back to the file. So here I'm just passing weights and some bias and the inputs in the neuron, and this is my output of the neuron. So if you will take the neural network, this is how it will look like. So neural network, I'll just mimic the same neural network for which we have seen the image. So the first hidden layer will have two neurons with some weights and bias. I'm just keeping the weights and bias same for all of them, but in practice it's not the case. We will see that while we look into the training of a neural network. So I'm just passing a weights and bias for each neuron and one in the output layer. Then in my feed forward, I'm just taking the first H1 output, second H2 output as output, and passing that as an input in my output neuron. So in this output neuron, I'm just passing them as an input, and this is our final output. Let us see how it will look like. Let me run the script. So this is our output of our final output of our neural network. So in this video, we have covered the neuron and the neural network. I'll create a separate video on how to train a neural network. So while training, after this feed forward happens, there will be back propagation, which will adjust our weights and the bias to train our neural network. We will look into that in the next video because that's a complex thing to explain and it will take some time. So see you in the next video. Thank you.